All right, so and I don't know where I put my pen. Hello, pen. There it is. So let's just jump right into some examples because we already have kind of our baseline with those properties that we did for the warm-up. So let's just use the property to complete each statement. Okay, so we're going to be kind of utilizing some of these properties that we just talked about in the warm-up there that we've got. And we'll kind of finish some sentences here, okay, to kind of help us out. So, for example, okay, I'm going to abbreviate some of these just so that we don't have to write the whole words out. It seems kind of silly. So we'll say for the addition property, okay, using that, if AB equals 5, okay, if AB equals 5, so we're talking about a segment length, right? Segment AB has a length of 5. Then 10 plus AB is going to equal what? 15. Okay, right? We're adding 10 to each side there. We add 10 to each side. Right? 10 was added to AB, so over here on this side, 10 was added to 15, or to 5, and we get 15. Okay, so that's kind of our answer there. Right? That's the addition property. We start with an equation, adding the same thing to both sides then results in still a true statement. Okay. All right, how about let's do a multiplication property example. If the measure of angle C is 30 degrees. Okay, if the measure of angle C is 30 degrees, then what times the measure of angle C equals 15 degrees? So we start with this equation. Measure of angle C is 30 degrees. If that's true, then what times the measure of angle C will give us 15 degrees? Madison? Negative 2. Negative 2 times measure of angle C will equal negative 2 times 30. That would give us negative 60, not positive 15. What? What's that? 0.5. 0.5. Or 1/2. 1/2, right? Yeah. I made it a little bit tricky there with the fractions, you know. Gotta throw in some fractions, though. Who loves fractions? Okay, 0.5 or 1/2 there. All right, let's try another one of these properties here. Again, using some geometry stuff. Let's use the reflexive property. Okay, here we go. BA equals blank. According to the reflexive property, what fills in the blank there? Jake? AB? Yeah, or we can say BA again. BA again. Okay. Something equals itself. I think AB would be okay there because it is telling them the same thing that way, but BA equals BA. Okay, cool. All right, let's use the symmetric property here. Okay. And we'll start with this if statement. If the measure of angle D is equal to the measure of angle C, then what follows by the symmetric property here? If the measure of angle D equals the measure of angle C, what would we then state using the symmetric property? Measure of angle C would equal the measure of angle D. Exactly right. Okay, not very exciting, right? It's kind of like duh again, but yeah, that would be. I don't know why I'm Not really doing a very good job sticking to my different colors there, but there you go. Okay, yep. You just flip the order around, right, with symmetric property. So that would be the result of using the symmetric property there, or applying it. All right, do 2 more here, and then we'll actually jump into a proof. Okay, transitive property. Okay, if yz equals db, so segment yz, if the measure of segment yz equals the measure of segment db, and the measure of db is equal to the measure of jk, then actually, I'm going to hold off on that. Then, what must be true using the transitive property here? Using the transitive property, what do we say? Okay, so again, if yz is equal to db and db is equal to jk, then what must be true? Brandon, what do you want to say? Y is equals jk. Very good. db is the thing that kind of bridges between yz and jk there, right? So very good. Yz equals jk. Okay. This oftentimes gets confused with like the substitution property. Okay, it kind of gets confused with the substitution property because you're like, oh, if this thing equals db, that means I can substitute yz in place of db, right? So sometimes this property gets confused with the substitution property because I'm saying these two things are equal, then that yz can substitute in for the db. And I can see that. It's a subtlety that I don't really care too much about, you know, like having you guys like differentiate between. So, all right, now we'll use the sub property though. We'll take a look at that. If mn equals 3, then 5 times mn equals 5 times blank, which would be what? What goes in the blank?
3.
Yeah, 3, right? We can just substitute mn for its equivalent 3 there, substitute it in, and so then we can say that's 15 then. Okay, we can substitute in a 3. Okay. And again, you could say, well, Mr. Whitmire, isn't that just the multiplication property? It's like, yeah, that you could really call also that the multiplication property there. Because we're taking a true equation and then multiplying by 5 on both sides. So, I mean, you could also call that multiplication property in that case. Other events with the substitution property will make some sense there. But for right now, we just say, yeah, it's multiplication. You could say substitution or multiplication there. Okay, so let's look at an actual proof. Okay, and we'll start with something that you guys are super familiar with, and you've probably done an activity like this before. But again, it's going to be helpful to help us bridge the gap maybe from what we are familiar with to that with which we are unfamiliar. Okay, so let's prove algebraic equations. Believe it or not, every time you solve an equation, you're kind of doing a little proof. Okay, except you don't always write your reasons out. So when you have a proof, you are normally given information, right? You need to have a starting place. You need like a base amount of information to then, get somewhere else. So here, our given information is this. 3 times the quantity 2x minus 4 equals 5x plus 2, right? You can't solve an equation unless you're given something to solve in the first place. So we need given information to us, okay? Oftentimes it's like the problem. Okay, but the nice thing is here, in a proof, you're also typically given your answer or your goal or the thing you are trying to prove. Okay, so in the majority of our proofs that we're going to be doing, we're going to be starting with given information, right? The problem, you can think of it in a sense, and then we're going to also be given our goal, what we want to attain. We want to get to the point where we can say, x is 14. Okay. And there's different ways to organize a proof. All right? So what you guys normally do in a situation like this is you will take this and make a bunch of statements, right? The first statement, you'll maybe rewrite the problem. And the second statement, maybe you'll distribute, right? And the third statement, maybe you'll move things to both sides or whatever, et cetera, et cetera. So let's go ahead and do that. So I'm going to organize those things. I'm just going to label them as statements. Okay? This kind of proof, this organization that we're going to use is called a two-column proof. You're used to doing a single column, but we're going to just add another column to the end, and you'll see what we do with it. So statements. The first statement, we always want to start with the given information. Always, always, always. Okay? When you guys are just solving equations on your own, you can, jump with doing some steps or something like that. But when we're doing a proof, an official proof, we want to start with the given information. And then over here, we're going to supply reasons for those steps that we're taking. So the reason why we can state this is true, the reason why we can state that this is true is because it was given to us. And so the first reason, since you're always stating the given first, the first reason will always be given. It was given to us. Okay? Again, these are like the why. Or sometimes they're the how do you know that's true. Okay? Are you keeping up okay, Daniel? Okay. So, what would be the next step that we want to do here to start solving this equation? Distribute. Okay, great. So let's distribute. So we'll get 6x minus 12 equals 5x plus 2. Okay. And why or how did we do that? What did we use? Distributive property. We use the distributive property. We know these things are still going to be equal because we used the distributive property. Okay. If you want to abbreviate, that's fine with me. Okay, just make it kind of obvious. So don't just do like D property or something like that, because D could stand for division or distribution, right? But if you want to do like DIST and then prop, that's fine with me too. Just make it obvious which property you're talking about there. All right, what should be the next thing that we do here? All right, what do you want to do next? Madison, what do you want to do next? Okay, so you want to add 12 to both sides? Okay, so let's do that. So if we add 12 to both sides, we're going to end up with 6x here equals 5x plus 14. And so you use the addition property there, right? I'm going to put in parentheses plus 12, just so that I can show exactly what I did there, right? Do you have to put that plus 12 in there? No. No? Okay, you don't have to. But it's just a little bit more detail to describe what we're doing here. All right, Avery, what did you want to do next?
Then you just subtract 5x from both sides.
Subtract 5x from both sides, okay. And so since we're subtracting, what would our reason be? Subtraction property, right. So I end up with an x here equals 14. And that was the subtraction property. Okay. And again, we subtracted minus 5x from both sides there. Okay. Did I have to use the subtraction property here to do what we just did? Is there another property we could have used? Besides subtracting 5x from both sides, could I have done something else to move that 5x over? Besides subtracting it? Anytime we subtract something, what else can we do? Add the opposite. So you also, technically here, instead of using subtraction property and minus 5x, you could say addition property and just put plus negative 5x. It's up to you. So there's more than one option there, right? Sometimes you have a couple paths to take to get to it. But we're done. We've proved it. We've gotten to what we were trying to prove. So that's the end of the proof there. Okay? That's the end of the proof. All right? We've got one more little proof here, and then we will get you guys started on your assignment. Okay? So we'll do one more little proof. This one's going to be an actual geometry proof. Okay? So we'll do an actual geometry proof here, just to give you a little taste. Okay. So given AB is equal to BC, given A, B, C, so B is between A and C, and given that A, B, C are collinear. So let me draw a little picture with that. So if we do all that, A, B, and C are collinear, and AB is equal to BC, so I'm going to put B like right in the middle so that AB is between BC and it's also the same distance, same length. Okay, so there's our picture. We can put little markings here to show that they're equal. Okay, what we want to prove is that AC equals 2 times AB. So given this information, we want to prove that AC is equal to 2 times AB. Now we believe it, right? We're just like, yeah, it makes sense, Mr. Whitmire. Of course. A to C is twice AB or twice BC, right? Because those are both half of AC, right? Makes sense. But to prove it, we believe it, right? But how do we prove that? So again, I'm going to start with some statements and then give some reasons. Okay, I'm going to draw a little 2-column chart here. If you want to make the chart, you can. You can just start writing it too like that. Okay. Where do we always start with our proof? The given information. So AB equals BC, ABC, and then sometimes the given information is necessary to use in the proof, sometimes it is not. Okay? Sometimes you're given extra information that you don't need, but sometimes not. Okay. So, we have to go from this information to this statement right here. And this is where proofs get difficult, because it's not always obvious what path to take, right? You guys have solved equations, for maybe years or at least months, okay? And so you've gotten so much practice with this, you have this like innate, intuitive sense about how to go from here to here. But remember, there was a time when you might be given an equation and you're like, I'm not really sure what to do. Right? Like, should I start subtracting 2 over, or should I divide everything by 5? You weren't sure what to do, and so you were stuck, right? But then eventually you developed a kind of sense about how things should be, done with the equation, and eventually you were able to do them. Now when you see them, you just have an intuitive sense about what to do, right? The same thing is true about proofs. When you try and do a proof, okay, that's not just like proving an equation, you may not always know which direction to go here, how to start, right? I mean, we at least know how to start, but then what should be the next step, right? And so that is something that we want to develop in this class some, is trying to develop how to know where to go next, okay? If you take a look here, some clues about what to do next. We have an equation given to us, and if you look, the thing we're trying to prove is also in an equation. So maybe we should try and focus on this right here, that AB equals BC. Okay, and maybe coming up with another equation here. In fact, what's another equation that we could set up here, right? Well, we could say, for example, AB plus BC equals AC. What postulate am I using to allow me to say that is true? Give people a chance to think about it here. Let's see. What postulate is that allows me to say that that's true? AB plus BC equals AC. It may not be on, and in fact, I'll tell you now, it's not on the properties we just did today in class. It's on a previous postulate that we've already talked about. What geometric postulate allows me to say that? There you go, segment addition, right? We're adding 2 segments together to get the bigger segment. So what's the reason I can say that? Segment addition postulate. So that's why we learn those kind of ground rules, because sometimes we're going to use those in these proofs here. Okay, now, I'm kind of making my way a little bit here. If you see, I've got AC equal to something over here. In fact, AC is equal to, it's got an AB already. I need two ABs, though. I have one AB. But what do I know about BC? It's equal to AB. So, can I replace BC with AB?
Yes.
Using what property? Substitution, right? We're going to plug it in and replace it. So I'm going to keep this AB. I'm going to add in, substitute in the other AB. Again, using the substitution property. And what's AB plus AD? It's going to be 2AB equals AC. And the reason for this, I don't even know I wouldn't even say it's the addition property of equality. It's just like simplifying, you might want to say. Or if you want to put like combining like terms or something. Okay, this one I don't know if there's really like a statement for it. It's just like you're just adding two things together, right? You're combining together, we add them, and we get 2AB equals AC. Okay, and so there it is, the thing we were trying to prove, 2AB equals AC. Okay, now it makes sense, right? The logic of it makes sense, right? And that makes sense. But of course, if you were to do that on your own, if I were to just give this to you, that would be a different story altogether, right? Because you maybe wouldn't know to go this kind of direction. Okay, so that's something we're going to develop, we're going to work on together as a class. Most of the proofs that we're going to see starting out here now, they're going to have the statements given to you, so that way you will be able to follow the logical flow of thought, and then you'll maybe have to fill in the reasons, how we know these certain things are true. Eventually we're going to work our way, though, to the point where I just give you this, and this is completely blank, and you fill in to the point where you can then get from here to here. Okay?
So every time we're proving, we have to do the statements and reasons?
Yes. Yes, but again, the proofs I'm giving you tonight, for your assignment, the statements are already given to you. It's a matter of you just give the reasons, okay? We're going to take baby steps, because this is not a trivial thing to do, okay? I'm asking you to learn how to do something like solving equations, whereas with solving equations, you did that over months. I'm asking you to do this in a matter of, a couple days, couple weeks kind of thing, okay? You have... but we won't be doing things maybe as intense as some of the equations that you've solved in the past, but it's not a trivial thing to learn. Not trivial. Okay? Questions on any of this process or anything here? All right. There's other ways to organize. I'll maybe show you those too eventually. But for right now, that's just going to be what we've got right for. We'll just go with this method right here. All right. In the meantime, I'm going to post this to our Google Classroom right here, okay? Hopefully those of you that had difficulties yesterday won't have difficulties today. If you do have difficulties, let me know, as soon as possible or whatever, and we'll try and get those worked out. I do want you to do those things. So for those of you, if you didn't get stuff done, get that done tonight. And it's just this, so it's pretty easy. You're just going to match these words then to the steps, and they're all equations. So it's like super straightforward about what you have to do, nothing too crazy. All right, but that'll be on the Google Classroom tonight for homework. Okay. Tomorrow we'll do a little bit more with proofs. We'll also do, tomorrow please bring in your Chromebooks. Does anyone still not have a Chromebook or device or something? Okay, so tomorrow please bring in your Chromebooks. We are going to be using them tomorrow. We're going to use a program called GeoGebra. Okay, so please bring your Chromebooks tomorrow. Please bring your Chromebooks. And I'll try to send out a remind for you too, so that way you don't forget. Charge it, charge it overnight. It's okay. They can take it